Welcome back to another problem solving video. This one is looking at a probability question. It says consider two independent events A and B where probability of B is 0.44 and the probability that A does not occur or B occurs is 0.74. Determine the probability that event A occurs. Okay, well. So the first bit of information is important. It says consider two independent events. Now, to test for independence, you have a couple conditions. First, you have the probability of A times the probability of B equals their intersection. Alright, and second of all, you have conditional probability A given B is just the probability of the outcome because it's independent, it's not conditional on the other event. So the probability that A will occur, given that B has already occurred, is just the probability that A will occur. Vice versa, probability that B occurs, given A, will be the probability that B is just occurring. So that's important. Okay, so the probability that B will occur is 44. And the probability that A does not occur or B occurs is the probability that A complement or B is 0.74. So, now this question's tough. It's not easy. To start off with, just write out this in a longer form to where you can start to substitute in some values and really kind of disaggregate the function to a point where you can manipulate it enough to get an answer. So the probability that A does not occur or B does not occur is the probability of A not occurring plus the probability of B occurring minus the probability of A and B, or A complement and B. Is 0.74. Now, due to the rule of independence, we know that A complement B is independent because A and B are independent events. Them not happening is not conditional on the outcome of the other one. If that makes sense, it's a little bit to think about. So we can write this again as the probability of A complement plus the probability of B minus the probability of A complement times the probability of B is 74. And that's due to the multiplication rule of independent events, which is stated here. And next, well, I see in our givens that we can substitute into values. So which is 0.4 here. The probability of B. It's the probability of A complement plus 0.44 minus the probability of A complement times 0.44 equals 0.74. So now we have more than one value. Before we just had the 0.74, and now we have a probability of the event B occurring, which is 44. So this is where we can start to rearrange and manipulate it algebraically a little bit. You want to deduct 0.44. Okay, so that's going to get rid of that. You're left with the probability of A complement minus the probability of A complement times 0.44 equals 0.3. And this last step, I'm just going to multiply 0.44 into the complement of A, which is very helpful because you just get 0.44 PA. Complement A, sorry, complement. It is the complement. That dash there indicates that it is not A, everything but A. And that's great because now you have P of A minus another factor of P of A. And think about this as 1. 1 minus 0.44 is 0.56. 0.56. P complement A, and that's going to equal your 0.33. And we finally get to a point where we can apply the rules of algebra, basic problem solving, and you finally get the complement of A. .536 if you add up, if you round up. Now, if that's the complement of A, to find P of A, which is what our problem was stating, it's disappeared. You go 1 minus 0.536, and you finally get the answer. P of A is equal to 0.464. And you can check if that's correct given the rule of independence. But in order to solve this problem, it really helps to know your rules and how they affect what conditions apply and what values you can use to figure out how to solve the problem.